This is the summary created from the video. Lecture 14 Demonstration VI. The lecture begins by demonstrating simple inheritance, where a class inherits from another, followed by multi-level inheritance, including the use of the super keyword to avoid name clashes. The super keyword is also discussed in the context of invoking the superclass constructor and referencing its variables. An example of simple inheritance is presented, where class A is the superclass with members ij and a show method printing their values. Class B extends A with an additional variable k and methods like sum printing the values of ij and k. By inheriting from A, class B gains access to its variables and methods due to inheritance and default access. The process of initializing subclass objects using superclass constructors is demonstrated. Box is the superclass with width, height, and depth as data members and constructors. BoxWeight is the subclass derived from box with an additional weight data member. The subclass object is initialized using its own constructor, passing values as arguments, while the superclass constructor is called from the subclass constructor using the super keyword to initialize its members. A subclass object can be referenced using a superclass variable, as demonstrated by the volume method for weightbox, which calls the subclass method to calculate the volume. A plainbox object, which is a superclass object, references weightbox, a subclass object. This kind of referencing a subclass with a superclass is legitimate, and calling the volume method for plainbox invokes the volume method of the weightbox subclass. The super keyword helps avoid name collisions between variables of the same name in parent and child classes. Class B inherits from A, and both have an integer variable I, leading to a naming collision. Super I refers to the variable I in the superclass A, while I refers to the variable in the subclass B. The program demonstrates printing the values of both the superclass and subclass variables using the super keyword. Runtime polymorphism is achieved through method overriding, where the method called is resolved dynamically. The cat class has a speak method that prints meow, while the subclasses petCat and magicCat override it. MagicCat's speak method .speak if known or true, otherwise, it prints hello cat. The demonstration shows objects of the subclasses petCat and magicCat invoking their overridden speak methods, highlighting dynamic binding based on the object's state. A multi-level inheritance example is presented, where abstract classes provide a blueprint for subclasses, defining methods that subclasses must implement. The subclass shipment is derived from BoxWeight, which itself is derived from the base class box. Subclasses can call the constructors of their superclasses using the super keyword for initialization, and objects of multi-level subclasses can be created and their methods accessed. Abstract classes cannot be instantiated, meaning objects cannot be created from them. However, an abstract class can be inherited by other classes and used as a superclass. If a class has an abstract method, it must be declared as an abstract class. Abstract methods do not contain any implementation code and are left blank in the class. Subclasses must provide concrete implementations for all inherited abstract methods. Abstract classes can have constructors to initialize member elements for subclass object creation. These constructors in abstract classes are called via subclass constructors using the super keyword. Although abstract class constructors cannot be directly invoked, they are useful for subclass initialization. A demonstration shows an abstract class base with a constructor and an abstract method, fun overridden in the subclass, derived, illustrating the calling of the base constructor from the derived constructor to initialize the subclass object state. An abstract class can have non-abstract methods that are accessible through the subclass object. The demonstration includes an abstract class with a non-abstract method overridden in the subclass. It shows how to create a subclass object inherited from the abstract base class and access the non-abstract base class method using the super keyword, clarifying that non-abstract methods and data in an abstract class can be accessed via the subclass object. A method declared final cannot be overridden in subclasses, maintaining the implementation's integrity. Final classes cannot be inherited, restricting class extensibility for design purposes. If a method is final, Any attempt to override it in derived classes will result in a compilation error. Declaring classes or methods as final allows controlled accessibility and prevents unexpected modifications. Final variables are constants, and their values cannot be altered after initialization. In summary, inheritance allows code reuse and the extension of existing classes, while overriding enables runtime polymorphism via dynamic binding. The super keyword resolves naming conflicts and calls parent constructors. Abstract classes act as blueprints containing abstract methods. Constructors in abstract classes initialize subclass objects, and non-abstract methods in abstract classes are accessible via the subclass. Final classes and methods restrict inheritance and overriding, respectively. Please stay tuned for more summary videos.